Okay guys, now we're going to talk about broken line graphs. Now, a broken line graph is again representing data. We have already collected it in tallies and tables. We've organized it in stem leaf diagrams. We've summarized the data. That was with mean, median, mode, range. And now we need to represent the data, make it look more user-friendly, right? And we're going to fill in a formula in here or a picture in there by the end of this lesson. We're also going to have some fun and look at some real life examples. So a broken line graph is a great way to represent data. A broken line graph shows a relationship between two quantities, right? Often using time as the horizontal axis, right? So what if we wanted to measure your height in centimeters over the years, right? So let's say you're 14 years old now, and this has been your height at age 1, at age 2, at age 3, at age 4, at age 5, age 6. Start to have a bit of a growth spurt around here, 8 to 9, 10, 11, and you got to 150 centimeters high. And this is what that graph would look like. Here we have time in years. It's age, it's years, but it's time. And this is on our first year you were 30 centimeters high. On our 8th year you were 70 centimeters high. And on our very last year, I've crossed out your 15 one, so ignore that. You were 150 centimeters high. Now, when you're drawing a broken line graph, firstly, you will see it's called a broken line graph because it has a whole bunch of juts around. It is not a continuous line. The next thing you'll know, you've got to fill in your axes properly. This is your height versus time. This is telling you what the graph is. We've got our height, and that is in centimeters. You've got to put in the units here. And then you've got your age, and that is in years. You've got to put your units in. You've got to label your axes, and you've got to label your bottom axes. Okay, I've cleaned this up here. And what if we were to plot this over more time? So let's say we plotted this until we're about 37, 40 years old. You will see that your height starts to decrease. You stop growing as much when you get about 180 centimeters high. Everyone will differ, but this is a graph showing your height over time. Now, again, like I said, it's broken line because you can see these lines go grit, grit, they're breaking. There's not a continuous line. A continuous line graph would be a graph that looked like this, like a function we're going to deal with in the future, where it's one continuous line. Right, let's have a look at some examples of broken line graphs. Let's take South Africa's monthly gigawatt hours electricity production. Right, so in January, South Africa requires 20,500 gigawatt hours, right? Just to let you understand how much that is, that's the equivalent of about 15 Koeberg nuclear power stations, just for your interest. February, it goes 20,800, March 20,300, and we go through the list here. So we create our graph. Electricity used in South Africa, gigawatt hours versus the months, right? So I've put this title here. What am I missing out on this graph? I need the electricity usage in gigawatt hours South Africa on the side here, and I need the months at the bottom, or time and the months. So make sure you write these. I just have not done this here because of space, but make sure you add these things in. So let's go and plot this. In January, the start of our data, we had 20,500. In February, we had 20,800. So let's go to February, great, 20,800. That's up there. Now, a good way to, if you are building this for the first time, to look at your axes, go through this list, find the range or the minimum and maximum. I had already done this. But you find your minimum and maximum, and then you can decide what to make your biggest number at the top and your smallest number on the bottom. Here our maximum number was, in fact, February at 20,800. So I made it 21,000. I just took it up a bit. And our lowest number here was 9,300, and I just took it down a little bit. Oh, sorry, it was 19,000 was over here, not 9,300. Okay, let's continue. March, we had 20,300. So March, we go up the line. 20,300 will be there, and that is March. Now, April will be 19,500. April, 19,400, 500, right there. May will be 19,000. That's our lowest month here. June will be 19,700. June will be 19,700, which will be there. Now remember, if you get your ranges wrong, don't be afraid to rub it out. That's why you should always do it in pencil to start with and redraw this axes. July will be 20,400 over there. August will be 20,300 over there. September will be 19,900. That's just about here. October will be 19,300 again. Oh, sorry. September will be 19,900. October will be 19,300, which is about here. And December will be 20,000, which is up at the top there. Okay, so now we can connect these lines. So we draw a line from there to there, there to there, there to there. Ooh, that's a bit skewed. Use a ruler when you're drawing these lines. There to there, there to there, there to there. And you see a bit of a pattern forming. There to there, there to there. And this is, I haven't drawn November. I've skipped out December here. That was my fault. November should have been 19,800. And then December would have been over there somewhere. And then we draw the last line. And if we say, for example, this was the year 2014, we can see that this graph probably connects here into the next year. So let's ask some questions about these graphs. Firstly, we plotted it and completed the graph. Great. Are there any trends? Right. So what does it mean when they ask us, are there any trends? Now, a trend is the exact reason why we draw broken line graphs. It's for us to figure out if there's anything we can tell about the future because of this historic data that we have got. Yes, we can tell there is a trend. In these months from April to June, it is a bit lower. From September to November, it's a bit lower. But then in June, July, it's high again, and then here it's high again. What does this look like? These are our seasons. This is summer, this is winter, this is autumn, and this is spring. That's interesting. The trend shows here that it's looking like it's doing a bit of an arch. It's going up and down, a bit of a snake or a wave. That would be the trend. So looking at this, we can predict what the next year's January is going to be. It's probably going to go up following the trend. Could you represent this data in a bar graph or histogram? Yes, of course you could. I would recommend doing it in a histogram. Why? Because the bins have time. They are continuous. A bar graph will work just as well, though. So what are the reasons or advantages of making a graph like this? You can imagine in South Africa, it is very important that we have electricity during summer and winter. And this graph tells us that. Why? In summer, you can see everyone needs air conditioners. In winter, everyone needs heaters. So the reason we would make a graph like this is to better plan the future. Imagine you were an engineer at Eskom and you could say, right, I've looked at this graph and I can see that in summer and winter, we're going to need the most electricity. So maybe we should plan to do all our upgrades and maintenance in these months here. Over here, the spring and April or autumn months. And that would be the best time because it's when we need the least energy. And that's exactly why we use data and make graphs. Okay, another real life example of a broken line graph is if we were to look at the weather in Cape Town. Now, why don't you go to Google and type the weather in your city, whether it be in Joburg, in Durban, or anywhere in the country. See the weather, or why don't you go and look at the weather anywhere in the world? And you can see the broken line graph we have here. During the middle of the day, it's the hottest, and as it goes into nighttime, 1 a.m. to 4 a.m., it starts getting cooler. Let's have a look here, Tuesday, this very sunny day. As you can see, it's very cold in the morning. At 4 a.m. it's cold, and it gets up to 25, where between 1 a.m. and 4 p.m. it's the hottest time of the day. Try something else. Try go the rand versus dollar, right? And here you can see another broken line graph. It looks like stock market kind of graphs of the rand slowly decreasing here against the dollar. This is over a 5-year period. And this is hopefully something you'll be able to change one day with the math skills you have learned. We've now done broken line graphs and we can fill in this diagram here. So well done.